This talk in the Building Minds with Patterns series is about the reaction pattern. We will briefly highlight the features of a generic cognitive architecture and discuss design patterns for cognitive systems. Then we will delve into the specifics of the reaction pattern. And finally, we will show how this pattern fits into some existing cognitive systems. What is a cognitive architecture? A cognitive architecture is a design for an artificial mind. It is realized in a diagram depicting the elements of the mind that the architects claim are necessary and sufficient to support thinking, otherwise called cognition. But how do we build such a system in the first place? The answer is simple. We need to establish a list of requirements identifying what the artificial mind will do. Once these requirements are elicited, we can then design a cognitive architecture to fulfill the requirements. So at a very high level, some initial requirements could be that 1. We want an artificial mind to communicate with a device, such as a car, a robot, a smartphone, or an avatar, that is situated in the real world or in a virtual world. 2. The device will send data, we can call these data observables, from the world to the mind, and receive commands from the mind. We can call these commands actuations. 3. Some components will think about the observables and infer new information about them. We will call these coordination components. 4. We will need to have the system learn and improve its behavior over time. The system will therefore need to observe its own performance. We will call the components that reflect upon the system's behavior reflection components. 5. We want the system to stay within its capacity for memory and performance and not get slower over time, so we will need to periodically consolidate the information stored in the system, and therefore we need components for that. These 5 basic requirements can be supported in many different architectures. We now present a generic cognitive architecture template. In essence, a cognitive architecture is a blueprint for an artificial mind. Here we see areas for observation, coordination, reflection, and consolidation, as well as the device situated in the world. In this template, we can see a device situated in a real or virtual world. This device communicates with a cognitive system through observation components, which store input from the device into the system's memory. The observation components are also responsible for communicating with the device's actuators, which perform actions in the world. We also see that there are coordination components which update the memory with new inferences. The reflection components are responsible for changing the overall behavior of the system. And finally, the consolidation components are responsible for ensuring that the memory does not exceed its available capacity. What are cognitive system design patterns? Isaiah Berlin once said, "To understand is to perceive patterns." In building an artificial mind, it's helpful to start somewhere, and preferably not from scratch. There are a number of cognitive system design patterns which can be used to implement the required mind functionality. Mapping requirements to design patterns can assist in defining the overall mind architecture. Some design patterns are depicted below. This talk's focus will be on the reaction pattern. What is the reaction pattern? Reaction is the ability to respond reflexively to one's environment. The reaction pattern is a loop wherein reliable actions are triggered by observables. This pattern is useful when immediate responses to observables are needed. The device, with its external sensors and internal monitors, is situated in a real or virtual world. The device sends observables, which are sensory data sets emanating from the device. The dataset may contain percepts, features, or urges, and drives, which are homeostatic deltas, as well as proprioceptions, which are confirmations that an actuation request was performed. These observables are sent to a perceiver component, which updates the observables in memory. From the observables, an overall context is formed, which is a situation containing the most recent observables. Then, a reactor component chooses the most reliable action applicable to the current situation and forwards it to the executor. Actions are formed from primitive actuations that the device can immediately execute. In addition to the primitive actuations, an action may be a policy, which has a set of preconditions necessary for the actuation to be executed. Or the action may be a macro operator, which contains both preconditions and expected effects, as well as a chain of actuations or sub-macro operators needed for the successful execution of the macro operator. The executor is responsible for taking an action and sending the actuations to the device. An actuation is an instruction or command that the device can perform. If the device attempts the actuation, it sends back a proprioceptive observable, indicating whether the actuation was in fact executed. That way, the system can track the reliability of the action. Forces for using the reaction pattern include the need for the system to perform in real time. What is a cognitive system? A cognitive system is a software and hardware implementation of a cognitive architecture. It is the instantiation of an artificial mind. There are a number of cognitive systems that have been researched extensively. Here is a chart of some cognitive systems and the design patterns they implement. Cognitive systems which have the reaction design pattern are highlighted in yellow with a red outline on the cognitive systems chart. In order for us to study cognitive systems, we have to align them so that their elements are comparable. The characteristics among cognitive systems that seem important are the ability to perceive information from the device, the ability to be reminded of prior events and situations, the ability to create, retrieve, select, and execute actions. These general regions are depicted in the comparison template, and the cognitive systems we study will be laid out accordingly. The cognitive robotic system is both reactive and deliberative. The reactor component responds directly to observables. Higher level components engage emotion and attention to make decisions. The complete autonomous agent is an architecture that explores modularity and specialized learning as it relates to neuroscience and artificial neural networks. Typically, behavior-oriented design follows a methodology wherein hierarchical reactive plans arbitrate among component modules. According to Joanna Bryson, complete agents function independently, while complex agents handle multiple conflicting goals with multiple mutually exclusive means of achieving those goals. Behavior-oriented design architectures overcome limitations in prior art by separating how an intelligent agent acts from when those actions are undertaken. The complete autonomous agent architecture lies at the intersection of neural and modular approaches. The active inference system by Friston and Associates evolves a hierarchical generative world model using surprise or free energy minimization. The theory assumes that an adaptive agent must maintain homeostatic states within limits. Endowed with priors describing its desired states and utilizing continuous sampling of the world, the model continually generates predictions which the system tries to fulfill. Paco Plus is a robotic system capable of creating, manipulating, communicating, and sharing perceptual, behavioral, and cognitive categories. It operates in the real world and interacts with humans by reflecting upon its perceptions and reflecting upon its actions as it models the world. This system was developed by the European Commission Cognition Unit. The Human Architecture by Owen Holland is a general cognitive architecture exploring the area of mental simulation and episodic memory. The Alpha Star system plays StarCraft II, a real-time multiplayer strategy game. The perceiver controls a camera which partially observes the game device. The system is initially bootstrapped by hand with thousands of prior games which provide the initial policies or strategies for actions to be taken. Policies are updated during gameplay by several learning components. The agents that are managed by the AlphaStar system are also individual neural networks. So to recap, the reaction pattern allows the system to respond reflexively to the environment. The forces for using the reaction pattern include situations where a system requires immediate responses to its environment. A device forwards observables to a perceiver component. The perceiver component aggregates the observables into the current situation. A reactor chooses reliable actions to execute and forwards them to the executor, which in turn forwards the actuations to the device. The device forwards proprioceptions indicating whether the actuations were performed as part of the observables back to the perceiving component. You can read more about this design pattern in the book Building Minds with Patterns, available on Amazon. If you found this information useful, please like the video and subscribe to the channel, and visit us on Patreon. Become a member so that we can bring you more helpful content. Find us on the web at Linktree. We'll see you in the next video.